Module 5, Descriptive and Inferential Statistics. What is the average cost to rent or buy a house? How much will you make with a bachelor's degree in the psychology field? What is the average commute time to work for people in my neighborhood? How much does the temperature fluctuate during the day? What is the most common type of transportation used by people in my city? How much money do people typically spend on groceries per week? How many hours of sleep do most people get per night? What is the average score on a particular test or exam? What is the most frequently ordered item on the menu at a restaurant? How consistent are product ratings from customers on an online shopping website? This list can go on and on and on, and descriptive statistics can be used to provide valuable insights into everyday situations and can help inform decision-making and understanding of various topics. Statistical methods play a crucial role in research methods, providing researchers with tools to analyze data, make inferences, and draw conclusions. Descriptive statistics are brief informational coefficients that summarize a given data set, which can be either a representation of the entire population or a sample of a population. They are broken down into measures of central tendency, measures of variability, measures of association, and involve summarizing the data so that it is easier for others to understand. Descriptive statistics summarize and describe the characteristics of data. Measures of central tendency, which are the mean, median, mode, and measures of variability, which are standard deviation and range, are used to describe the distribution of variables within a sample. Measures of central tendency refers to the statistical measures that represent the central or typical value of a set of data. These measures help researchers summarize and understand the central value around which the data points tend to cluster. Central tendency is used to summarize data, compare different groups, and gain insights into the distribution of variables in psychological research. The three commonly used measures of central tendency are mean, median, and mode. The mean is the arithmetic average of a set of values. It is calculated by summing up all the values and then dividing the sum by the total number of observations. The median is the middle value in a dataset when it is arranged in ascending or descending order. It represents the point at which half of the data values are above and half are below. The mode is the most frequently occurring value in a dataset. It represents the value that appears with the highest frequency. Many variables in psychology, such as intelligence, personality traits, and physical characteristics, tend to follow a normal distribution, which can be seen as on a bell curve diagram. In statistics, the term bell curve refers to the shape of a specific probability distribution known as the normal distribution. The bell curve is named for its characteristic bell-like shape when plotted on a graph. The mean, median, and mode are all located at the center of the distribution, forming a peak in the middle of the curve. The distribution of IQ scores in the general population are often standardized, with a mean of 100 and a standard deviation of 15. When these scores are plotted on a graph, they tend to follow a bell-shaped curve. In this distribution, the majority of individuals cluster around the mean IQ score of 100, forming the peak of the bell curve. As you move away from the mean in either direction, the number of individuals decreases, resulting in the tapering tails of the curve. The bell curve for IQ scores is useful in understanding intelligence as it allows researchers to compare individuals' scores relative to the population. According to the bell curve, approximately 68% of individuals have an IQ score between 85 and 115. Measures of variability provide summary statistics to understand the variety of scores in relation to the midpoint of the data. It provides descriptive information about the dispersion of scores within data. It provides important information about the degree to which individual data points deviate from the central tendency. Three common measures of variability are range, variance, and standard deviation. The range is the simplest measure of variability. It is calculated as the difference between the maximum and minimum values in a dataset. Variance measures the deviation of each data point from the mean. It quantifies the spread of the dataset by considering how much the values deviate from the mean. Standard deviation is a measure of how much individual data points in a dataset tend to differ from the average or central value. For example, if you have a group of friends, and you want to understand how much their ages vary from the average age of the group. If the standard deviation is small, it means most of your friends' ages are close to the average age. On the other hand, if the standard deviation is large, it means their ages are more spread out, with some being significantly younger or older than the average age. Measures of association are statistical techniques used to quantify the strength and direction of the relationship between two or more variables. These measures help researchers understand how changes in one variable are related to changes in another variable. For example, finding out the number of hours spent studying and the corresponding test scores for a group of students. We want to determine the relationship between study hours and test scores. A strong positive correlation means as the number of study hours increases, the test scores tend to increase as well. Inferential statistics is a branch of statistics that involves making predictions, inferences, or generalizations about a population based on information obtained from a sample. Unlike descriptive statistics, which summarize and describe the characteristics of a dataset, inferential statistics aim to draw conclusions about a larger population by analyzing data from a smaller subset, known as the sample. Key factors of inferential statistics include population inference, parameter estimation, and hypothesis testing. The goal of inferential statistics is to make inferences or draw conclusions about the entire population based on information obtained from a representative sample. By using appropriate statistical techniques, researchers aim to generalize their findings from the sample to the larger population. Parameter estimation involves approximating population parameters using sample data. The goal of estimation in statistics is to estimate or approximate a population parameter based on information obtained from a sample. In statistical inference, researchers often have limited access to data from an entire population, so they rely on collecting and analyzing data from a smaller subset of the population, known as a sample. Estimation allows researchers to draw conclusions and make inferences about the population using information from the sample. Hypothesis testing is a common application of inferential statistics and uses data from a sample to draw conclusions about the test group. Hypothesis testing is a method of making inferences about a test group based on sample data. A method that allows you to reject or fail to reject the null hypothesis and allows you to tentatively accept the alternative hypothesis when the null hypothesis is rejected. The null hypothesis represents the default position or the absence of an effect. It states that there is no significant difference or relationship between variables in the population. Researchers formulate null and alternative hypotheses about the population and then analyze the sample data to determine whether there is sufficient evidence to reject the null hypothesis in favor of the alternative hypothesis. The null hypothesis is typically formulated to be a specific statement of no effect or no relationship. It is often the hypothesis that researchers aim to reject or disprove in favor of an alternative hypothesis. The alternative hypothesis states that there is a significant relationship or difference between variables. The alternative hypothesis represents the researcher's claim or the presence of an effect. It states that there is a significant difference or relationship between variables in the population. The alternative hypothesis is typically what researchers are interested in investigating and supporting with evidence from their study. It proposes a specific direction or nature of the relationship or difference between variables. If we want to investigate the relationship between caffeine consumption and reaction times in a cognitive task, the null hypothesis might state there is no significant relationship between caffeine consumption and reaction times in the cognitive task. The alternative hypothesis would state there is a significant relationship between caffeine consumption and reaction times in the cognitive task. The researcher would test these hypotheses on participants' caffeine consumption habits, like how many cups of a caffeine drink they have each day and their reaction times on a cognitive task. After analyzing the data, researchers would determine if there was enough evidence to reject the null hypothesis in favor of the alternative hypothesis. If the results show a statistically significant relationship between caffeine consumption and reaction times, researchers will reject the null hypothesis and conclude that there is a significant association between the two variables. This would suggest that caffeine consumption does influence cognitive performance on a task. On the other hand, if the results do not show a significant relationship, researchers would fail to reject the null hypothesis and conclude that there is no strong evidence to support the claim that caffeine consumption has a significant effect on reaction times on a cognitive task. Parameters in statistics are important concepts related to data analysis and inference. They help researchers understand and make inferences about populations based on sample data. Parameters are numerical characteristics of a population. They represent the true values of variables of interest that researchers want to estimate or describe. Since it is often impractical or impossible to measure the entire population, researchers use sample data to estimate population parameters. Examples of population parameters include the mean, standard deviation, correlation coefficient, population proportion, and population effect size. Statistics are numerical characteristics of a sample. They are computed from the sample data and serve as estimates or approximations of the corresponding population parameters. Statistics are used to describe and analyze the sample and make inferences about the population. Examples of statistics include the sample mean, sample standard deviation, sample correlation coefficient, sample proportion, and sample effect size. After conducting data analysis, the researcher needs to report their findings accurately and clearly. The researcher has an obligation to conduct well-designed studies and to communicate the results. The basic structure of a typical research paper is the sequence of introduction, methods, results, and discussion. The researcher will present the research paper through articles in journals to the scientific community. The introduction section introduces the topic of the research, provides background information, and presents the research question or hypothesis. The goal of the introduction is to give readers a clear understanding of the research's purpose and significance. In the methods section, the researcher explains the methods and procedures used to conduct the study. It includes details about the study design, participants or subjects, data collection methods, equipment used, and any statistical analyses applied to the data. The results section presents the findings of the study, including statistical analyses, effect sizes, and any significant or noteworthy results. The findings of the research are arranged in a logical sequence without bias or interpretation. The results section should include the statistical tests used, the levels of significance, and summarize data such as group means. The discussion section is where the researcher interprets the results and discusses their implications. The findings are put into context with existing literature and the research question is answered or hypotheses are addressed. Strengths and limitations of the study are also acknowledged here. Scientific papers are usually submitted to peer-reviewed journals, where they undergo a rigorous evaluation process by experts in the field before publication. Peer review is a critical step in the publication process of scientific papers. It involves the evaluation of a research manuscript by independent experts in the same field of study. Peer reviewers assess the quality, validity, and significance of the research, providing feedback and recommendations for improvement. Reviewers evaluate factors such as the appropriateness of the research design, clarity of the research question, soundness of the methodology, interpretation of the results, and overall contribution to the field. Peer review helps ensure that published research meets high standards of quality, accuracy, and integrity. It also provides an opportunity for researchers to receive constructive criticism and refine their work. The goals of scientific research are to systematically investigate, understand, and expand our knowledge about the natural world and the universe. These goals are pursued through the scientific method, which is a systematic approach to observation, measurement, experimentation, and the formulation, testing, and modification of hypotheses. The scientific method has 4 goals: describing the research, explaining the research design, predicting the outcome, and controlling the research environment. The researcher aims to accurately describe and document natural phenomena, processes, and events. This involves gathering detailed and objective data to provide a comprehensive understanding of the subject under investigation. Researchers seek to explain why certain phenomena occur and to understand the underlying mechanisms or principles that govern them. This involves formulating theories, models, or hypotheses to provide causal explanations for observed patterns or relationships. The researcher often strives to make predictions about future events or outcomes based on the patterns and relationships identified in the data. Predictive models and theories can help anticipate potential outcomes and guide decision-making. Understanding and controlling various factors that influence a phenomenon is another goal of scientific research. This allows the researcher to manipulate variables to test causal relationships and assess the impact of interventions or treatments. One natural and expected aspect of statistical sampling is sampling error. Sampling error is the difference between a population parameter and a sample statistic used to estimate it. It occurs when a subset of individuals or items, the sample, is selected from a larger group, the population, to make inferences or draw conclusions about the entire population. For example, the difference between a population mean and a sample mean is sampling error. Sampling error can be reduced by carefully planning the study. For example, a researcher is interested in studying the average level of anxiety in college students at a particular university. The total population of college students at that university is 10,000 individuals. However, due to time and resource constraints, the researcher can only survey a random sample of 500 students from that population. The researcher administers an anxiety questionnaire to the selected sample of 500 students and calculates the mean anxiety score for this group. The sample mean will likely be close to the true population mean, but it is unlikely to be exactly the same. The difference between the sample mean and the true population mean is the sampling error. Understanding and accounting for sampling error is crucial for drawing valid conclusions from research findings. Thank you for watching our videos on research methods in psychology. We hope that you'll continue your studies in this area and that you'll let us know if you have any questions or feedback. Best of luck on the final exam.